Good morning, guys. So in our previous discussion, we looked at the direct utility function and the indirect utility function. In this video, we are going to look at a second approach, that is what we call the expenditure function. Now, with respect to expenditure function, we ask this question: what is the minimum level of money expenditure that a consumer must make in order to achieve a given level of utilities? Is it okay? So the problem now becomes, in this case, we have our expenditure function, which is a function of u, and u is always equals to we minimize our expenditure subject to our utility with a function of s greater than or equals to a given u, right? So this is, we are trying to minimize expense because as a rational consumer, you always aim at what? Minimizing your expenditure, but trying to achieve what? A certain given utility that you want. So that is the aim here. Now, the solution, so just like what we did for the previous ones, we're going to set up our Lagrangian. Now, when you set up your Lagrangian and you differentiate respect to your x1, x2, and all that view, whatever you solve, the optimal x1, x2 that you are going to get, or the optimal x's that you will get, is what we term as what the compensated or Hicksian demand function. The compensated or the Hicksian demand function is okay. So let's say we have, just like we did, now we have our expenditure function, and we've been given a certain utility. So let's look at, let's say, this utility function, just like the one that I used. Example, we have this CES utility function, which is giving us, let me look at it and write. Utility with a function of x1, x2 is equals to, let me check the question, is equals to x1 phi plus x2 phi. It's okay. With this 1 over 5, yeah, with 1 over 5, it's 1 over 5. Great. So this is the utility function that we have, and we've been asked to derive the expenditure function from this. So first of all, what you have to do is to set up your Lagrangian. So I'm going to set up my Lagrangian. Now, because it is a minimization problem, the Lagrangian becomes first the expenditure function we want to minimize. So expenses are what? P1, we have two commodities, X1, X2, with their respective prices, P1, P2. So P1 multiplied by X1 plus P2 multiplied by X2. That will give you the total expenditure, right? So P1, X1 represent the total expenditure on commodity 1. P2, X2 represents total expenditure on commodity 2, right? Because it is a minimization problem, we make it minus lambda into bracket x1 phi plus x2 phi 1 over phi minus the u. It's okay. So now this becomes our Lagrangian function. So first of all, we are going to differentiate this respect to x1, x2, and the lambda. So we are just following the same process that we did for the previous one. So when I differentiate respect to x1, I'm going to have is equals to, when I differentiate this part, I'm going to have P1. Then in this second component, there's no x1, so I don't touch it. Now when I go to the third one, what is this one? When I differentiate, I'm going to have minus lambda multiplied by 1 over 5, 1 over 5, yeah, into bracket x1 phi plus x1 phi plus x2 phi 1 over 5 minus 1. Then I differentiate this expression here, and that gives me phi x1 phi minus 1, and I equate it equals to 0. So this is called equation 1. Now the second one is to differentiate respect to x2. Now when I differentiate respect to x2, I'm as well going to have P2 minus lambda into bracket, so 1 over 5 into bracket x1 phi plus x2 phi, all into bracket 1 over phi minus 1 multiplied by phi x1. So this is x2. One differentiate respect to, so I'm going to differentiate what I have here because I'm differentiating respect to x2, right? x2 phi minus 1 equals to 0. So this becomes equation 2. Now when I differentiate respect to lambda, I'm going to have it as when I differentiate with respect to lambda, I'm going to have it as respect to lambda is going to give me the utility function back, which is going to give me x1 phi plus x2 phi 1 over phi minus u equals to 0. So this becomes equation 3. So we have 3 equations now. Okay, sorry. So this is because there's a minus here, so this is going to be minus. This is going to be minus, and this one will be plus. But at the end of the day, we are going to have it because when it equals to the equation, it's going to be u is equals to x1 phi plus x2 phi 1 over phi equals to 0. So this is the same as the equation 3. Sorry. So just like I always do, let's differentiate equation 1 by equation 2. Now when I differentiate equation 1 by equation 2, I'm going to have it as P1 over P2 is equals to lambda multiplied by 1 over phi into bracket x1 phi plus x2 phi into bracket 1 over phi minus 1 multiplied by x1 phi, so phi x1 phi minus 1 all over lambda 1 over phi x2 phi plus, sorry, x1 phi plus x2 phi 1 over phi minus 1 multiplied by phi x2 phi minus 1. So this expression here cancels this expression, and this one cancels this. So that means we have it to be reduced to P1 over P2 is equals to x1 phi minus 1 all over x2 phi minus 1, right? So I can just do cross multiply. This multiplies this, this multiplies this. Then I have P1 x2 phi minus 1 is equals to P2 x1 phi minus 1, right? So I want to make x1 the subject from here. I can divide this side by P1, and this cancels this. Then I can say x2 is the same as this phi1 times 1 over phi 1 is equals to P2 over P1 exponent 1 over phi minus 1 multiplied by x1, because this x1 will also be multiplied by 1 over phi minus 1, and this will cater for this, like this one has catered for this one. So I have x2 is equals to phi 2 over phi 1 into bracket 1. Okay, so this one here, 1 over phi minus 1 multiplied by x1. So I'll call this one equation 4, right? So this is equation 4. Like, so great. So from here, I can say let's put equation 4 into equation 3. So put equation 4 into equation 3, right? And that is going to give me the equation 3. So what? U is equals to x1 phi plus x2 phi 1 over phi, right? This is equation 3, right? So wherever I see equation 3, I'm now going to replace it with what? Wherever I see x2, because we made x2 the subject. So wherever I see x2 in equation 3, I'll just replace it with equation 4. So that means I can say u is equals to x1 phi plus, but in equation 2, equation 3, equation 4, we know that x2 is now what? P2 over P1 multiplied by phi over phi minus 1, because there's a phi here, right? Multiplied by x1 phi. This one is being added because of what? The phi attached to x2. But when you check what we have in equation 3, there wasn't any phi. But once it is part of is here, we just have to multiply it by it. It's okay. So you have it as this, and then multiply by our 1 over phi. Great. Right. So there's a common factor, which is what? X1 phi. So I can take x1 phi out. Now when I take x1 phi out, I'm going to have x1 phi, but there's already another exponent here, which is affecting what? X1. So times 1 over phi multiplied by, now here becomes 1. There's no more s1, plus phi 2 over phi 1, then phi over phi minus 1 is okay, and then 1 over phi. Great. Now this cancels this. Then I have u equals to x1. I can also simplify this expression. Now, if I want to simplify this expression, it is going to be what? P1 phi over phi minus 1 plus P2 phi over phi minus 1 all over P1 phi over phi minus 1 multiplied by 1 over phi. Great. So let's try and simplify this in order to make it simple. So from here, we're trying to make x1 the subject, right? So x1 is now equals, I can say from here, I'm going to say x1 is u, u is equals to x1 again. I'm just trying to simplify everything here. Phi 1 phi over phi minus 1 plus phi 2 phi minus 1 over phi over 1 over phi, then P1, yeah, the down power was P1, right? P1 here, phi over phi minus 1, yeah, exponent 1 over phi, right? So that means this phi here can cancel the phi here at the top, right? So that this one becomes P1 over 1 over phi, right? P1 exponent 1 over 1 over phi. Then I can multiply this by this. Then I will have P1 1 over phi minus 1 multiplied by u is equals to P1 phi over phi minus 1 plus P2 phi over phi minus 1 over phi, right? Great. 1 over phi multiplied by x1. So when I divide this expression by this, then I'll have x1, which is now a function of what? P and u is equals to P1 1 over phi minus 1 multiplied by u all over P1 phi over phi minus 1 plus P2 phi minus 1 all over phi. Great. Then exponent 1 over phi. So this becomes, so this is what the Marshallian, this is the Hicksian demand function for what? X1, which is a function of this, yeah, u, a function of only P and U. So we call this expression, we call it the Hicksian or the compensated demand function for what? X1. Now, once we know X1, we can replace this into equation 4. And that will give us the compensated demand function for what? X2. So if I'm looking for X2, then that is going to give me X2 is equals to, we said X2 was the same as what? P2 all over P1 1 over phi minus 1 multiplied by x1, right? Now we solve for x1 and we know x1. So I'm now going to replace x1 into this. So I will say x2 is equals to, let me simplify it, P2 1 over phi minus 1 all over P1 1 over phi minus 1 multiplied by x1, and we know x1 to be what? We got x1 to be P1, 1 over phi minus 1, multiplied by U, all over P1, phi minus 1, plus P2, phi minus 1, all into bracket 1 over phi. Great. So this expression cancels this expression here. Then we have x2, which is also a function of P and U, as being equals to P2, 1 over phi minus 1, multiplied by U, all over P1, phi over phi minus 1, plus P2, phi over phi minus 1, exponent 1 over P. So this expression here is also known as what? The compensated demand function for commodity 2. It's okay, so that's the same as the compensated demand function for commodity 2. Now, we said if you are looking for the expenditure function, right? Then the expenditure function, which is a function of P and U, right? Is the same as what? P1 multiplied by the x1 Hicksian, which is a function of P and then U, plus P2 x2 Hicksian function, Hicksian demand function for 2, right? So this expression represents what? The expenditure function. Now we know our x1, right? We also know our x2, so we're just going to substitute this into this. Then I will say that my Hicksian expenditure function is now equals to what? P1 multiplied by the Hicksian demand function for what? Commodity 1, which we know to be what? P1, 1 over phi minus 1, multiplied by U, all over P1, phi over phi minus 1, plus P2, phi over phi minus 1, then 1 over phi, plus P2, 1 over phi minus 1 U, all over P1, phi minus 1, plus P2, phi over phi minus 1, then 1 over phi. So yes, so now this becomes the expenditure function. You have to simplify it from this point. Yeah, from this point, we have to simplify it from this point. Great. Now we are going to simplify. Look at something. So sorry, there's supposed to be this is for this, and this is also for this. So there's supposed to be a P2 here because it's being multiplied by P2, right? So look at this the exponent here. So this P1 is multiplying the numerator, which is there's also P1 here. So the exponents are the same, right? So once the bases are the same, then you add up the exponent, right? So if I'm going to add up the exponent, like say 1 phi minus 1 plus 1, because this is P1 exponent 1, right? It's equals to 1 plus P minus 1 minus the phi minus 1 all over the phi minus 1. Is okay? So this cancels this. So you have this as phi over phi minus 1. Great. Then that means I can say the expenditure function, which is a function of P and U, is equals to P1 phi over phi minus 1 multiplied by U, all over P1 phi over phi minus 1 plus P2 phi over phi minus 1 over phi plus P2 phi over phi minus 1 multiplied by U, all over P1 phi over phi minus 1 plus P2 phi over phi minus 1, or exponent 1 over phi. Great. Now I want to simplify it. Now when I simplify it, it's going to be the common factor is what? The U. So I can say then expenditure with a function of P and then U is equals to P1 phi P1 phi okay, so that becomes P1 over phi minus 1 all over phi plus P2 into bracket phi over phi minus 1 or U and P1 phi over phi minus 1 plus P2 phi over phi minus 1 and then 1 over phi, right? So when you check the numerator here, this expression here and this expression, right, that their bases, so they are the same, but this is exponent 1 and this is exponent 1 over phi. So in according to the normal law of indices, when you have something like this, I can decide to subtract this one from the top, right? So I can say this expenditure function is the same as phi 1 phi minus 1 all over phi plus phi 2 phi over phi minus 1, yeah, then 1 minus 1 over phi multiplied by U is okay. Now 1 minus 1 over phi is the same as what? It's the same as phi 1 over 1, this expression here, 1 minus 1 over phi is the same as what? Phi minus 1 all over phi is okay. So great, that means this expression here can be changed to phi minus 1 over phi is okay. Now let's try and simplify this thing here. So let's say we use let's phi minus 1 over phi be represented with what? R is okay. If that is the case, now if phi minus 5 over 1 is represented with R, then I can say this expression here, right, which is what? Phi minus 1 over phi is okay. Sorry, I think there's a mistake in trying to put everything. So let me clear it. I think there's a mistake. Clear my drawings for this part. Great. So the expenditure function, let's look at the previous one that we got. We were at this point, right? So great. It was rather phi over phi minus 1, but not phi minus 1 over. So it's the expression here. It was what? Phi over phi minus 1, but not phi minus 1 over phi. Great. So that means, let me go back to the expenditure function. So the expenditure function now becomes E with the function of P and U is equal to what? So I'm going to have it as what? P1 phi over phi minus 1. I mistakenly wrote it as what? Phi minus 1 over phi, but it's supposed to be phi. Great. Plus P2 phi over phi minus 1, right? And then U here all over P1 phi over phi minus 1 plus P2 phi over phi minus 1, then exponent 1 over phi is okay. So like I said, look at something. This is everything is exponent 1. Now, so because the bases are the same, that means I can just subtract the denominator from the numerator. So that is going to give me P1 phi over phi minus 1 plus P2 phi over phi minus 1, 1 minus 1 phi, then multiply by your U is okay. Now 1 minus 1 phi is the same as what? Phi. So this is the same as, let me write it here. So this expression here, 1 minus phi is the same as what? Phi minus 1 all over phi is okay. The same as this. So that means then I can say the expenditure function is now the same as what? Phi 1 phi minus phi plus phi 2 phi over phi minus 1 exponent grace. So this one becomes exponent. So it becomes exponent phi minus 1 over phi multiplied by u, right? So let's try and then simplify this using something to represent the phi minus phi over phi minus 1. So let's say if I say, so let's say let phi over phi minus 1 is equals to what? R is okay. If that's the case, then don't forget we also have an expression like phi minus 1 over phi, right? So then if this expression, if you are using this to represent this, then I can say when I reciprocate, I'm going to have what? Phi minus 1 over phi is equals to what? 1 over r is okay. Then I can say the expenditure function is now what? Equals to P1 r plus P2 r, or into brackets 1 over r multiplied by the u is okay. So I've just used this to represent r, and this also to represent r, and now this expression here becomes what? 1 over r. So that's what exactly what I've done. This expression here is now 1 over r. So then that gives us the expenditure function, which is now what? Expenditure is a function of what? Prices and utility. So now this becomes our expenditure function, right? So in our next video, we are going to look at situation whereby you have your indirect utility function and you derive the expenditure from it without going through this long approach. That is what we call the duality concept. So I'm going to treat that in my next video. Thank you. And do not forget to subscribe to my channel and always watch my video. Bye.